See, BGP is a path vector routing protocol. Path vector. Why we call like that? Because it shows the autonomous system path via which we learn the routes. In another word, we can say AS by AS routing protocol, because it shows the autonomous system path, which is nothing but AS, autonomous systems. So every one hop is one autonomous system. So if you want to compare this, you can compare this to RIP, but RIP, every hop is a router, whereas for BGP, every hop is an autonomous system. See the second line. In BGP, the next hop does not mean next router. It means the IP address to reach next autonomous system. So, when you learn route, you're not going to see the immediate next hop IP address most of the time, because we form neighbor using loopbacks. Only that neighbor address will be reflecting as an autonomous system's ID, autonomous system's gateway, autonomous system's address. It is not the physical interface address or the very next router's address. See, the third point. For eBGP, the default next hop is the IP address of the neighbor router that sends the update. For iBGP, the BGP protocol states that the next hop advertised by eBGP should be carried into iBGP. What does it mean? You see, let me draw and explain. If I am forming neighbor using loopback, assume using loopback, according to this router 2, the neighbor address is 3.3.3.3. So now, when a network here, let's say here, I got 13.0.0.0/8. This is the network that autonomous system 20 is advertising. When router 2 learns it, it won't show this IP address. Let's say here the IP address is 10.23.0.3. Here the IP address is 10.12.0.2. Now when you see this 13 network, you will see the next hop address as the address of the neighbor. According to router 2, who is the neighbor? It's 3.3.3.3. This is what next hop, because router 2 forms neighbor with the loopback address of router 3. So router 3 is going to source all the packet with this, because you might have also said what? Update source loopback 0. So according to autonomous system 10, autonomous system 20 is identified as 3.3.3.3. So that is what going to be shown as the next hop. Now, very important, focus. When router 1 learns it, how it will learn? 13.0.0.0 is 3.3.3.3. But router 1 and router 2 are IBGP. For IBGP, BGP protocol states that the next hop advertised by EBGP, what is the next hop advertised by EBGP? 3.3.3.3 should be carried into IBGP. See, it is carried. It is carried. It is not changed. Even though router 2 is advertising this, router 2's address won't be seen as the next hop. Router 2's address won't be seen as the next hop. Whatever EBGP gave as the next hop will be carried into IBGP. So far clear? These 4 lines? Please ask me a question if you have. You need to check your mic, Ramesh. I know you are saying something, but it's only kill for me.
Sir, can you explain the diagram, sir? 1 second.
Okay. You see, we got 2 routers in the left which belong to autonomous system 10 and 1 router in the right which belongs to autonomous system 20. Autonomous system 20 is advertising a network called 13.0.0.0. If autonomous system 20 is advertising it, what will be the next hop seen in router 2 for the 30 network? It will be seen as the neighbor's address. According to router 2, the neighbor router 3, which is in EBGP, router 3 is in where? EBGP. The next hop will be the IP address of the neighbor router which sends the update. Please understand, even though the neighbor router is router 3, it won't be 10.23.0.3 because I said we are forming neighbor using loopback. If router 2 is forming neighbor with 3.3.3.3, then the next hop will be also 3.3.3.3. It won't be 10.23.0.3. Though it is not clearly explained here, that is what actually. Router 2 will not see autonomous system 20. To reach autonomous system 20 as 10.23.0.3, it will see only the loopback because we are forming neighbor using loopback. In EBGP, it's very rare to form neighbor with loopback, but you see in the previous class we learned that if you want to form neighbor with loopback, it needs to be a pingable address, so we give static root, we increment the TTL value, we also say update source. Because you are now sourcing with the loopback, the loopback address is what going to be seen as the next hop. Now when router 2 advertises this update to router 1, router 1 should know that this 30 network is received from 3333 because 3333 is what the idea of next autonomous system. So router 2 will not say I am giving you. If router 2 says I am giving you, then this will not be a next autonomous systems ID. BGP is autonomous system by autonomous system routing protocol. So if router 1 receives this 13 network, it should know from which autonomous system it is coming, and the ID to reach the autonomous system. According to autonomous system 10, autonomous system 20 is identified as 3333. So it is carried inside IBGP. See, for IBGP, the BGP protocol states that the next hop address advertised by eBGP should be carried into IBGP, which means router 2 cannot put its own address. Usually, protocols like OSPF, EIGRP, they put their own address. But this is not IGP protocol, this is BGP. BGP is AS by AS routing protocol. So router 2 cannot put its own address. It has to simply carry the address given by eBGP. That's what you see here. You see an example. If you have any confusion in what I said in the previous slide, that will be fixed here now. See, router A is advertising a network. This is the network 172.16.0.0. Router B is learning it. What will be the next hop address? 10.10.10.3. Why? Because that is the address with which B is forming neighbor with A. They are not using loopback. In my example, I was using loopback as the neighbor address. So I said 3333 is the next hop, not 10.23.0.3. But in here, the neighbor between B and A is using physical interface address. So when router B receives 172.16.0.0, the next hop address is 10.10.10.3. Now, when B advertises the same network to its IBGP, what is the relationship between B and C? It's IBGP. They are in same autonomous system, you see. 6500. It keeps the next hop. Meaning when router C learns 172.16.00, even though router B is giving this, usually if router B gives, this will be the address. 172.20.10.1 will be the next hop. But in BGP, that's not the case. In BGP, the next hop for this will be 10.10.0.3. Ask me a question if you have now. Why BGP is doing this? Because it is autonomous system by autonomous system routing protocol. The next autonomous system should be seen as the next hop. Next autonomous system is 10.10.10.3. According to C router, what is the next autonomous system? A. So A's address will be seen as the next hop. It's not B's address. B is not a next hop. B is not next autonomous system. Yeah, any question? Unmute and ask question if you have. Unmute and ask. Alright, which means there is no question.
Aaron,
Yes, please.
so default behavior BGP, right? Without loopbacks, nothing.
Repeat again, please.
No, this is the default behavior eBGP router to reside IBGP, right? Push forward.
Yes. Yes.
So doesn't matter if we neighboring with loopback. Doesn't matter.
No. Listen. If you are using neighboring with loopback, I've said in the previous example which I drawed physically with my hand, I was telling you we are forming neighbor using loopback. When I was forming neighbor with loopback, the loopback address was the next hop address.
Okay. So
here they are forming neighbor with physical interface address.
Okay. Extra command update source will be there, but
yes.
nothing. Default behavior will be there, right?
Yes.
Okay.
Now next page. So in order to forcefully change the next hop address, why should I change the next hop address? Listen, we just saw router C will have this address as the next hop. But tell me, can C ping 10.10.10.3? No. Why it won't ping? Usually, we will not be running IGP protocol here. So this network will not be advertised to this router using your OSPF or EIGRP because there won't be OSPF, no OSPF. You run OSPF only here, not here. Yeah, usually we don't run over the WAN interface. So when router C learns 172.16.00 with the next hop 10.10.10.3, because this router C do not know who is this next hop, because router C don't know the reachability to this next hop, because it cannot ping this address to the next hop 10.10.10.3, it cannot ping. Router C will not be able to use this BGP update. Router C learns a network, but it cannot use the network in the routing table for packet forwarding. The reason is the next hop address is unreachable. This router C do not know where it located, where that 172.0. It says 10.10.10.3 is the location, but where is the 10.10.10.3? Don't know. Because there is no route for 10.10.10.3 in the routing table of router C. There are two ways to solve the problem. One, make router C to know where is this 10.10.10.3 by running OSPF here also on this link. You don't need to run OSPF here, but at least here, so that this network will be advertised to C, and C will say, now I know the next hop, so I'm going to use it as best. What does this greater than symbol means? Best. Because router C knows now 10.10.10.0 network. When you run OSPF, if you are not willing to run OSPF there, means if you are not willing to advertise 10.10.10.10 the WAN interface network to router C, what you should do is you should say next hop self. Meaning, you need to go to router B and say, router B, do not keep 10.10.10.3. Means do not simply carry. Just change it. Put your own address. Instead of sending 10.10.10.3, he don't know what is 10.10.10.3. So better you put your own address. So you need to tell BGP, tell that you are the next hop self. Tell him you are the next hop. This is what the next slide was explaining you. When you say neighbor 172.20.10.2 next hop self, router B will advertise this 172.16 with the next hop 172.20.10.1. Now router C how to reach this network because it's directly connected. It will be valid and best. You see? We say neighbor address, next hop self. That is what here I explain. For router B, who is the neighbor? 172.20.10.2. Neighbor address. In router B, you configure this. Neighbor address of router C. Router C, don't worry, I'm your next hop. Who is telling that? B is telling that. But by default, B's address won't be the next hop. A's address will be the next hop, but A cannot be reached by C. In that case, we want B to be the next hop by breaking the next hop behavior. The next hop behavior is to advertise only the next autonomous system's address. But when we do like that, C cannot reach next autonomous system because there is no root. So we forcefully all the updates for this neighbor to be advertised with the router as the next hop. Instead of autonomous system as the next hop, we make this router as the next hop. Then the IP address used in the next hop self option will be the same as the source IP address of the BGP packet. So what happens to the source now? B becomes the source instead of A. A sends the update to B. B usually will tell C that A has given you this. But this time when you say next hop self, B is not saying A gave you this. B is telling I am giving you this. B is telling I am giving you this because you said next hop self. You ask B to say you yourself be the next hop. So now what happened? Listen to this picture. If you don't understand previously what I said, you'll understand it now. There is a network called 10.0.0.0 in router A. There is a network here. That network is advertised with the next hop 172.16.111 to router B. But router C don't know about 172.16.11, correct? Router C do not know about 172.16.11 because it's not inside the autonomous system. So what we say is we go to router B and say whenever you speak to 3333, just tell yourself as next hop. So B is going to say I am giving you this. B is changing with its own address as the next hop. Instead of 172.16.11, it puts its own address and sends to C. And C will use its own address as the next hop when it is advertising to D. Because according to D, the next autonomous system is 172.168.1.2. Is this clear? Long silent. If it is clear, please tell me clear. We'll go to the next one.
In the diagram, B is telling to A, right?
Repeat again.
And the diagram, the configuration from B, it is telling to A, right? This is my
Yella. Next stop address is who? 3333. Then why it will say to A? And see the direction here. It's telling to C.
Okay.
It's telling to C. The next stop is me. 2222. Still you have question? Put it in the right way. I don't understand your question.
Okay, as per, my understanding, B, C, normal behavior will take neighbor as 2222, right?
No, listen. There is a network here, okay? Called 10.0.0.0. That network is advertised by A now. You see the arrow mark? A is advertising the next stop. When it is advertising, it will put its own address as the next stop. Is it doing that?
Yes.
Yes. Now B receives. The normal behavior is when B gives to C, it will not be 222, it will be 172.16.1.1.
Correct.
But can router C reach this 172.16.1.1?
No.
Anduke, we ask B to put its own address by putting this command next stop self. We are telling B, whenever you talk to your neighbor, who is router B's IBGP neighbor? Tell me.
C.
Whenever you speak to him, just put your own address. So when it puts its own address, because we run EIGRP, because we are running EIGRP, C knows where is 2222. So when it learns with this next stop, C is happy to use it.
Okay.
But when C advertises to D, it won't advertise next stop as 2222. It will put its own address because it's EBGP. You understood?
Yes, sir.
Okay. Let's go to the next one. Little more complicated. Not really. If you try understanding, it's simple. Next stop for multi-access network. You see here there is a multi-access. To reach A, you can go via C like this. You can also go via B like this. Multi-access. Or in another word, in another direction, if A wants to go to this D, it can go like this. It can also go like this. Because it's multi-access. This is actually a switch in the middle. Now, the following takes place in multi-access network. Router B advertises 172.30 to router A. This is router A. Router A is learning 172.30.0.0. Can someone say where is 172.30.0.0?
C.
Router C, sir.
Okay. Router C is advertising this network. Actually, router C is advertising this network, and router B learns it. Why? Because C and B is what? IBGP. C and A is not EBGP. There is no connection, there is no BGP session between these two. BGP session is via B. C is forming IBGP with B, and B is forming EBGP with A. So, when B advertises this network to router A in EBGP with next hop, what will be the next hop? 10.10.10.2. It advertises and B will just keep the same address. See? When A receives this, even though it is forming neighbor with B, B is actually 10.10.10.1. But A will not be learning as 10.10.10.1 because the original source is reachable from here like this through a LAN switch. So the next stop will not be 10.10.10.1, it will be 10.10.10.2. But are we forming neighbor with 10.10.10.2? No, we are forming neighbor with 10.10.10.1. Why it is like this? This helps to avoid unnecessary hops. So you don't need to go a long way like this. You can take the shortcut like this. See how smart is BGP. So simple what I said is, when we learn 172.30.0, the next stop will be 10.10.10.2. It won't be 10.10.10.1. This is all BGP's default behavior. In multi-access, this is how it will work. BGP is being efficient by informing 64520 of the best entry. Best entry is this to reach this network. That's what the cleverness, the efficiency of BGP. So router B in autonomous system also advertises to this that the best entry part for each network is the next stop is C, because that's the best part. Very simple, nothing more than that. Actual story is explained here, and in the third paragraph nothing is there. They are repeating the same thing which we speak in paragraph 2 and 1. So these are all the things that we should know beforehand we enter into BGP's configuration. This is how BGP behaves. Without knowing this, if we go, then you will be surprised to see why router C address is seen in A, when router C is not a neighbor to A. C is not neighbor to A, B is neighbor. But whose address is shown? C's address. It will be a surprising thing for you. Any question on this page?
So the solution is A to C, correct, right?
Repeat again.
The solution A to C is the best path, right?
According to the routing table, to reach 172.30.0.0, going via B and then to C is not route. It's not a best route. Even though B is giving the update, B itself will give the C address as the next stop, because for A reaching C directly is feasible, closer, shortest, best.
So then what configuration next option on which router we need to do?
No configuration is needed for this. We are just learning the default behavior. When you have multi-access, usually we expect B address should be appearing in A as a next hop, but that is not going to be true, because the best entry to reach autonomous system 65000 to reach 172.30.00 is 10.10.10.2.
Okay.
Here no extra command needed. No next stop self, nothing. Next stop self was previous scenario. If
Okay, so since it is directly connected, no need to do anything in this device, right?
correct.
Okay.
Sir,
Yes.
sir, இப்போ 10.2 and 10.3 வந்து டைரக்ட் கனெக்டட். ஸோ பெஸ்ட் ரூட் வந்து இப்படி A to C வந்துருச்சு, கரெக்டா சார்? ஸோ இப்போ இந்த பக்கமும் ரூட் கொடுக்கும், இப்போ ஐபிஜிபி வழியும் போய் ரூட் கொடுக்கணும் சார். இந்த 172.30.0.0 அப்போ லூப் எதுவும் அவாய்ட் ஆகாதா சார்?
No. See, A will be very clearly knowing that C is the best entry. So it will never try to send to B. Only if it sends to B, then there will be a loop. It will never send to B. So loop is avoided. Even if B advertises, what it will advertise? It will say 172.30.00 next stop as 10.10.10.2. It is not going to advertise its own address. So there won't be any loop. If my answer is not clear, then ask me the question more clearly. I'll try to answer clearly.
இப்போ C2A வந்து 172.30.30.0 ரீச் ஆயிடும் சார், C2Aலயே. ஸோ அப்போ அகைன் C2B, அப்போ B2Aலிக்கும் 172.30.0.0 வந்து நம்மளுக்கு ரூட் கிடைக்கும் சார். சில இருந்து வர ரூட் ரெண்டு வழியா ரூட் கிடைக்கும். ஸோ பெஸ்ட் ரூட் வந்து ஏன்னு சொல்லிட்டீங்க. ஸோ பி வழியா ரூட் கிடைக்கும் போது அப்போ ரூட்.
You are telling the story just opposite. Story is not that C to A. Story is A to C. Update is coming from C to A, but traffic is going from where? A to C. This is the network advertised from C so that A can reach that network, meaning A is reaching C. A to C, it is not C to A. For this network, the next stop is going to be 10.10.2. This is what exactly going to be advertised by B. Now A clearly knows that the next stop is like this. Now how loop will occur, you tell me? Question. I'm asking question. How loop will occur here? Tell me please. Is it clear?
Clear, sir.
Yeah, Murli.
Hello. So since it is directly connected, A number is C, right? So the default, as his question, default behavior from C to A, the BGP default behavior, the next stop should be 172.30, but there is no reachable, correct?
Why you are confusing yourself? I don't understand. Repeat the question.
So the question is same his question.
Mike, no, don't say his question. His question I answered. If you have the same question, you tell it's my question and tell me the question.
My question. So A to C, C is a neighbor, direct connection. There's no problem.
No. C is not a neighbor to A. A and B are neighbors. See the EBGP arrow mark, blue color arrow mark. A and B are neighbor. B and C are neighbors. So now C is advertising a network. What is the network? 172.30.0.0. C is advertising this network and B learns it. B gives it to A now. But when B gives to A, it won't put B's address. B won't put its own address. B will put C's address and send it. Why? For A to reach C is shorter directly than going via B. And B knows that because it has got the route information. See the second paragraph. BGP is being efficient by informing. See a nice English put there. BGP is being efficient, means BGP is clever by informing 64520, which is router A, of the best entry point to 65000 for 172.30.0.0 as 10.10.10.2 not 10.10.10.1. But who is giving this? B only giving this. B only gives A is the best entry for you. Question.
Okay, but what about the default behavior in this case?
This is what default behavior.
Okay.
This is what default behavior in multi-access. In the earlier cases, we were not having multi-access.
Okay.
So this is the default behavior in a non-multi-access, and this is the default behavior in a multi-access environment. See, the previous case, is there any other connection like this to C?
No.
No. So it was not multi-access. It was just single point. Whereas here you got multi-points. You can go to this way. You can also go to this way. Multi-access. In multi-access, if any route coming from here, B will be the next stop. But route coming from C, C will be the next stop, even though C is not a direct neighbor. Because BGP is clever, it wants to avoid unnecessarily you going like this. When there is a path like this, BGP wants you to go like this. Best entry path.
Okay. So, in that case, we should mention the neighbor should be 10, 10, 10, 10, 2, right?
Neighbor should be what?
10, 10, 10, 2.
Ledandi. Look into the dotted line. The dotted line explains the neighbor.
Okay.
A's neighbor is 10, 10, 10, 1. Not 2. But BGP is clever. That's why you are having this presentation, this page, why they give you, because they want to show why BGP is clever, how router B is clever. Router B says, I am your neighbor, I am very happy to be your neighbor, but there is a change. What? For reaching this network, don't come to me, better you go to my friend. I have my friend who is 10, 10, 10, 2. Better you go to him. Who is telling that? B only gives that information that go to C, and A is going C directly.
Okay.
This is something which we cannot imagine, right?
Yeah.
That is why BGP is special protocol.
Okay.
Normally, no protocol will do like this except BGP. That's why BGP is special. See, normally if it is OSPF, you will be going like this. Come on. You will always go like this to reach this network. Even though there is a path like this, you will not be able to use it. Because the next stop will be 10, 10, 10, 1. That is normal. Normal OSPF behavior or EAGR behavior. The next stop will be 10, 10, 10, 1, not 10, 10, 10, 2. But BGP is slightly different from the normal. It provides the best entry point.
So, one last question. From A perspective, C is EBGP, right?
For A's perspective, C is not EBGP. C is not EBGP. B is EBGP.
Okay.
A mi sambandham ledu. A to B there is no connection. Sorry, A to C there is no connection. A to B have got connection. A to C ఏమి సంబంధం లేదు. No connection.
Okay.
Is this clear now? Alright. So next, peer group is a different topic. We'll talk about this in the next class. So we have learned the default next stop behavior. See, the last point is very important. For IBGP, the BGP protocol states that the next stop advertised by eBGP should be carried into IBGP. When you carry like that, not every inside router will know how to reach eBGP. To override that behavior, we use the next stop self command. Like this. And then in a multi-access, even though A and B is neighbor, B will recommend A to go via C to reach 172.30.0.0 because that's the best entry point. When we do the lab, actually we will not be doing this lab immediately. After learning the next topic called peer group, I'll be demonstrating this. The peer group will take maybe another 15 minutes. In our next class we'll cover this. Followed by I'll do the demo for both peer group and this next stop behavior. Right, we'll stop here today.